Good day. Today we're going to look at modeling with trig graphs. Now real quick, I'm just going to throw this out there. For a lot of these problems, for most problems in modeling with trig graphs, it is easier to use cosine than sine simply because you are talking about maximums in the problem, and you can transform them using cosine easier since it is already as a maximum value. Alright, number 2. Write the trig equation for the function with a period of 5, a low point of -3 at x equals 1, and an amplitude of 7. Now to write these equations, I'm going to identify my a, b, c, and d values. Alright, we have a period of 5. My period is equal to 2 pi over b. So b is equal to 2 pi over the period, 5. My a value for this says there is an amplitude of 7. Now, this middle part, a low point of -3 at x equals 1, is very important. First, let's say this is a low point. This tells me I need to have a negative a value. The low point is -3. This tells me my vertical shift, because if my lowest is -3 and I add 7 to it, I can get my midline of 4. Lastly, this occurs at x equals 1, which means I'm shifting this to the right 1 unit. Therefore, c is -1. Okay. My equation, y is equal to -7 cosine. Let me fix that first c. Cosine of 2 pi over 5 parenthesis x minus 1 plus 4. You can go in and try number 1. Now we're going to look at a couple of problems. I think I'm doing 3. Yep, I want to look at 3 with you, and I'll let you do the rest for your work today. Ruby has a pulse rate of 73 beats per 1 minute and a blood pressure of 121/85. Her blood pressure can be modeled using a sinusoid. Okay. For my a value, I want to find the distance between my maximum and minimum. So this is 121 minus 85. And that's 36. I need to divide this by 2 for halfway, and that gives me 18. This is tied to my d value. Instead of subtracting, though, I want to add 121 plus 85 over 2. That's 206 to give me 103. Or you could have just done 85 plus 18. Really, it's your choice. Okay, let's look at the 73 beats per minute portion. 73 beats per minute tells me I have 1 over 73 is equal to 2 pi over b. When you solve this, you're going to multiply by b, divide by 1 over 73. Either way you want to solve this, you get b is equal to 146 pi. It just says find the equation, so we're finished. Y equals 18, cosine of 146 pi for the C value. It said nothing about a vertical or a horizontal shift. My C is none. There's my equation. I'm finished. Let's look at number 5. A city averages 14 hours of daylight in June, 10 in December, 12 in March and September. Assume that the number of hours of daylight varies sinusoidally over 1 year. Write an expression for n, the number of hours of daylight, as a cosine function of t. Let t be the months, t equals 0 is January. What is the average amount of daylights in August? So real quick, let's list out these months. January is 0. February is 1. March is 2, and so forth. April, I should probably put APR. May, June, July, August, September, October, November, and finally the best month, December. Okay, those are the numbers that correspond per month. Write an expression for n, the number of hours of daylight, as a cosine function. Let's look at the top problem, and I want you to see that 14 hours of daylight is the maximum in June. We have 10 hours in December as a minimum. So for my A, 14 minus 10 over 2. For my B value, I'm going to go with that maximum occurring in June. So I'm going to say this is right 5 units, so -5. For my period, B is going to be 2 pi over 12 months, which is pi over 6. Lastly, my D value is 12. This gives me my equation. Y equals, actually let's put n of t, that's the way he wants me to word it. N of t equals 2 times cosine of pi over 6 times t minus 5 plus 12. Okay, there's my equation. What is the average amount of daylight in August? For this, I'm going to type this in Desmos. Now, you should get in a habit of the very first thing you type or do in Desmos for these problems is converting this from degrees into radians. Now, I'm not doing that yet because I want to show you what it looks like if I don't. My x-axis is from 0 to 11, so I'm going to back this up to negative point. Let's just do negative 0.5 to 11.5. That should give me a good view. My maximum and minimums are 10 and 15, so I'm going to say 9. 10 and 14, I mean, but 9 and 15. So my graph should be oscillating across this domain and range. Notice the degrees is highlighted right now. I am in degree mode, not radian mode. It should be in radian mode, but look at the graph. The graph is almost a straight line. Radians. That is a much better picture. Let's check what it says about March and September first. It says in March and September it is 12 hours of daylight. Y equals 12. This is 2 and 8. If you consult this chart that we have, it is March and September. So our graph is correct. Now let's answer the question. What is the average amount of daylight hours in August? August is 7, so I'm going to look where x is equal to 7. 13 hours. So my answer is about 13 hours. Okay, that problem is finished. I'm going to do one more and let you try the remaining. Number 8. Number 8, in my opinion, is the hardest because of the subject. It is talking about electrical current. Something I want to point out to you, electrical current can be negative. Okay? Negative for current means direction. So it is perfectly fine to have negative current. Now I made another note there for you that the period is 1 over 60. I'll show you why here in a minute. An electrical current alternates with a frequency of 60 cycles per second. It's what we use in our homes. At time 0.1, the current is at its maximum of 5. Write the equation, and what is it at 0.3 seconds? Okay, here we go. My A value is 5. It is the amps going through this circuit. My B value is 2 pi over the period, 1 over 60. This is a 120 pi. My C value is negative 0.01, and I have no vertical shift. Okay, that's all the information from the problem. Here's my expression. I of t is equal to 5 times cosine of 120 pi times t minus 0.01. Okay, let's type this into Desmos. Once again, I need to make sure I'm in radian mode. I am. Five cosine 120 pi x minus 0.01. See this black blob? That is my graph. Well, let's read the question first. What is the current at t equals 0.3 seconds? So you might think, well, you know, I'm going to have 0 to 1 second because 0.3 is between that. And I can go negative 5, but I'm going to put 6 to 6 to get both sides. But still, look at this graph. Why is it like that? That goes back to my second note there. My period is 1 over 60. So if you want to see the oscillation, one full cycle of this, notice that my maximum occurs at 0.01 seconds. I'm going to back this up to 0.09 seconds. If it occurs at 0.01, it says my period, I missed a 0 in this, my period is 1 over 60. I'm going to add 1 over 60. There is one cycle. That is a much prettier graph, and you can see the entire cycle here. Okay? So this is correct. I just want to show you why it looks funny if you don't know how to zoom in appropriately. What is the current at t of 0.3 seconds? Well, I'm going to type in x equals 0.3. I'm going to go to my domain, make this 0.29, make this 0.31. There's my answer. I of 0.3 seconds is approximately negative 4.05 amps. Or if you wanted to do it another way, you could have just put in 0.3. Done. All right. I'm going to go through and show you all the problems. Please pause the video and try the ones we have not done as your work for today. So you have 1 and 4. You have 6 and 7. And you have 9 and 10. All right, that is all I have for you today. Have a great rest of your day.